This one's waves lesson 2, and this one's the wave equation. The objectives are to perform calculations using the wave equation, and that's it. Alright, let's make a start. So, to start, we're going to need the wave equation, and its speed or wave speed is equal to frequency multiplied by the wavelength, or V equals F times lambda. Now, if you've not seen that before, it's just a Greek letter. Literally, you draw it like that. So lambda, like that, just a Greek letter, and it means wavelength. So the units, the wave speed is in meters per second. Wavelength is in meters, and frequency is measured in hertz, or cycles per second. If you want to pause and make sure you've got that down, then I'm going to show you how to rearrange the equation. So I'm going to do that now. Okay, here we go. So it's V equals frequency times wavelength. So if we want to find frequency, we need to get rid of a times. So let's make F the subject. If we want to get rid of the times lambda, so the opposite of times by lambda is dividing by lambda. So frequency would be V divided by lambda. So that would be, there's two equations. And the other one would be the wavelength. So if we wanted a wavelength instead, we need to get rid of a times frequency. So we would simply divide by frequency on the other side. So the wavelength is wave speed divided by the frequency. Okay, so the three equations. Well, it's the same equation, it's just written in three different ways. I'd advise you to practice doing that on your own, but if you're really struggling, you know, the different formats, or you want to check the different formats are there. The equation's not on any data sheet unless you're sitting your exam in summer 2022. Hopefully they change that, but at present there's no plans. Alright, let's move on, let's do some questions. Start with this one, dead straightforward. Calculate the speed of a water wave of wavelength 3 meters and frequency 6 hertz. If you want to pause and have a go at that, and then I'll take through the answer. I'll do that now. So wave speed is frequency times wavelength, and it's simply 6 times 3, which gives a wave speed of 18 meters per second. Really straightforward. So the next one, so calculate the frequency this time of a wave in water of wavelength 2 meters if its speed is 16 meters per second. So that should be relatively straightforward. Let's pause and have a go. I'll take through the answer. So wave speed is frequency times wavelength, and to get frequency, as we've already seen, you need to get rid of the times lambda, so we need to do the opposite, which is divide. So frequency is wave speed divided by wavelength, and that's 16 divided by 2, which gives us a frequency of 8 hertz. Okay, let's move on to another one. So this one, let's pause and have a go. I'll take through the answer. Calculate the wavelength of a sound wave in water of frequency 300 hertz if its speed is 1500 meters per second. Sound obviously travels faster in water and even faster in solids. The denser the material, the faster sound will travel. So wave speed is frequency times wavelength. So wavelength would be wave speed divided by frequency, and it'd be 1500 divided by 300, which gives a wavelength of 5 meters. Let's do some more. So this one's a bit of an extension question. Hopefully you've watched the previous lesson. Calculate the speed of a wave that has a wavelength of 30 meters and a time period of 0.04 seconds. If you want to pause and have a go at that. And then I'll take you through the answer now. So for this one we need to, well, you could just find the frequency first. So that would be frequency is 1 divided by the time period. So 1 divided by 0.04, which gives us 25 hertz. And then use the wave equation. So the wave speed is just frequency times wavelength. So we've got the frequency, which is 25 multiplied by the wavelength of 30, which gives us a wave speed of 750 meters per second. Hopefully that one went okay. Okay, let's try some more, because why not? So a quick table. If you want to pause and find out the missing information. You don't have to write the table, you can do if you wish, or you can treat it as, you know, just 4 different questions and show you working out. So the first one, So that would be wave speed is frequency times wavelength, so 15 times 4, which gives us 60 meters per second. The next one, for the second one, would be frequency. So frequency would be the wave speed divided by the wavelength. And that gives us 330 divided by 2, which is 165 hertz. The next one is the frequency again. So that would be wave speed divided by wavelength. So that would be 300 million, which is coincidentally the speed of light, divided by 1,500 meters. So that must be some long wave radio wave. So that's a frequency of 200,000 hertz. And the last one, you've got to be really careful because you've got 300,000, but it's kilometers per second. So you actually need to multiply that by 1,000 to turn it into meters per second. And remember, 100 megahertz is 100 million. So if you've done standard form, 100 million would be 100 times 10 to the power of 6. Or you could simply write 100 million hertz. Both the same numbers. It just depends if you've done standard form in maths. Or you may have done it in physics. You may be okay. But either or, it doesn't matter if not. And wavelength. So we start with V equals F lambda. So wavelength, we need to get rid of a times the frequency. So we need to divide by frequency. So wavelength is simply the wave speed divided by the frequency. So that'd be 300,000 kilometers, or 300,000 times 1,000 meters per second, divided by 100 million, which gives us 3 meters. Okay, let's try an extension question. So you want to pause and have a go at this one. Calculate the frequency of red light of wavelength 680 times 10 to the power of minus 9 meters and wave speed 3 times 10 to the 8 meters per second. Just out of interest, if you do want to check, that is the actual wavelength of red light, or, you know, red light's got a bit of a range of wavelengths, but that's one of them, and that's the wave speed. That is the speed of light. So let's pause and have a go at this one. So remember, the wave speed is equal to frequency times wavelength. Sorry if this isn't the neatest. And then we're finding frequency, so we need to get rid of a times lambda, so we need to divide by lambda. So frequency is equal to the wave speed divided by the wavelength, and then we just need to put our numbers in. So hopefully, if you can do standard form, the wave speed is just 3 times 10 to the power of 8. If you haven't got a calculator, it's just a 3 with 8 zeros after it. By calculator, I mean scientific calculator. Divided by, and then we've got 680, and then times 10 to the power of minus 9. And that will give you a frequency that's equal to 4.4 times 10 to the power of 14 hertz. If you got that, very well done. Let's move on to a closed exercise. So if you want to pause and have a go at this, you can either, obviously you can copy the entire thing out and fill in the blanks, or you can list 1 to 8 and just write the keywords where they would go. So I'm going to go for the answers now. So a wave transfers energy without the movement of matter from one place to another. In a transverse wave, the particle vibrations are perpendicular, which means at 90 degrees to the direction of wave travel. Frequency is equal to the number of waves produced by a source in 1 second. Time period is equal to the reciprocal. Reciprocal is a fancy word for 1 over that you may have come across in maths. And if you haven't come across it in maths, you've come across it now. If you want to Google it, feel free. Might be useful. The speed of a wave in m/s, or meters per second, is equal to its wavelength in meters multiplied by its frequency in hertz. So that's the wave equation. I hope you found that helpful. And thanks for watching, and I'll see you at the next video.